This video will show a testing operation of 500 watts shortwave amplifier with a TFT touchscreen. So bands could be changed manually, but the best way is to use the automatic mode with the band decoder, as I do. The only voltage required for this amplifier is 50 volts. The voltages are being produced inside. This is the 50 ohms down the load to represent a good antenna. This is the 25 ohms down the load. The reference power meter is a Bird 43 with element for 2500 watts on shortwave bands, 2.5 kilowatt full scale. I will drive it with the ISO transceiver. This amplifier is made for 5 watts input power. Every 100 watts shortwave transceiver will produce a huge ALC spike. To fight this effect, I'm going to use the 6 decibel attenuator. So the power is set to 20 watts. It must be divided by 4. So 5 watts only comes to amplifier input. Internal power meter is calibrated here on 20 meters. As you see, 500 watts, same level as here. Okay, and I will show how it works, band by band, starting from 160 meters. And then some telegraphy manipulation. SSB, 1, 2, 3, 4, 5. Easy to see that instant power in SSB mode is much stronger than in CW. Okay, now let me return to packet mode on 20 meters on the central frequency of shortwave band. Now I will replace a good antenna by worse one. 25 ohms will represent SWR on output as high as 2 to 1. If I try to transmit, high SWR protection will be enabled. To reset it, I have to switch main power supply and wait for a few seconds to discharge the capacitors. But if I reduce the driving power 2 times down, 2.5 watts, the amplifier will operate at this power level, but somewhere close to 5 and 5 watts will cause the protection to enable. Now I return the 50 ohms dummy. Return now 5 watts. If I overdrive the amplifier, say 6 watts on input, high current protection is enabled. On some bands, high power protection will be enabled to protect the amplifier. I switch it off, reduce the power to 5 watts. And show that everything is okay.